take a look at one-sided limits of polynomial functions. We call a polynomial function is a function of the form p of x equals an x to the power n plus an minus 1 x to the power n minus 1 and so forth down to the lowest power, which is the power 0. So the subscript represent the same as the power of the x, where each exponent is a positive integer, and an minus 1 and so forth up until the a subscript 0 are real numbers. If p is a polynomial function and a is a real number in the domain of the polynomial function p, then the limit of the px as x approaches a from the left equals limit of the px as x approaches a from the right, and it is exactly the same as the function value of that polynomial function at a. Another way, the polynomial function value is the same as the left-sided limit and the right-sided limit. Or when we compute the one-sided limits of the polynomial function, we are going to find it by finding the value of the polynomial function at that point A. Another key term that we're going to use it later on, if A is in the domain, so then the limit of the function as x approaches A is going to be the same as the function at the point A, but make sure A is in the domain of that function. So let's take a look at the example. We're going to find the value of the following, find the value of the one-sided limits. In part A, the function is negative 3x plus 8, which is definitely polynomial function. And the a value, a is 2. So it doesn't matter the left-sided limit or the right-sided limit. The limit of the polynomial function is the same as the polynomial function value at that point. So we're going to plug it in. Wherever you see x, we're going to replace it with the value 2. And then simplify the number to be the value of this one-sided limit. So negative 3 times 2, that's negative 6, added by 8. The result is positive 2. In part B, another polynomial function that we see. Okay, so the a in this case is negative 1. We are finding the right-hand limit as x approaches negative 1. When we see x, we replace with negative 1. Quantity power 2 minus 8 times the x now is replaced with the value a, which is negative 1, and then plus 3. Next, we simplify the numbers. For negative 1 squared, that is positive 1 times 4 becomes 4. Negative 8 times negative 1 becomes positive 8, and then plus 3. Now we have 4 plus 8, which is 12. 12 plus 3 becomes 15 as the result, as the right-hand limit of this function. In part C, the function that we have, this is not a polynomial function. Why is not? Because it's not in the form of x to the power integer and so forth, because it's divided by x. So not polynomial. Make a note here. If it is not a polynomial, we consider the a that we have here, a equals 1, is a1 in the domain of this function. So let's see, the domain of this function is the set of all real numbers as long as x cannot be 0. Why is not be 0? Because the 0 going to make it undefined. So a is 1, 1 is not 0. So then a equals 1 is in the domain of this function. Therefore, the limit of this function is the same as the function value. I'm rewriting it because it's kind of getting messy here. So x approaches 1 positive of this function x plus 3 over x is the same as you replace x with the 1. So 1 plus 3 divided by 1 or 4 as the answer for part C. Now we move to the next one. Again, this one is not a polynomial because in the fraction form, or we call this the rational function. If it is not a polynomial function, again we consider the domain. The domain is the set of x such that x cannot be 3. And check what is our a. Our a is 0. Yes, 0 is not 3. So therefore, a is in the domain of the function x plus 3 divided by x minus 3. Similar to part C. I'm gonna separate this is part C and D. So then let's rewrite it again. So limit of x plus 5 divided by x minus 3 as x approaches 0 negative, or the left hand limit, is gonna be the same as you replace the x with a 0. That's the a value there. So 0 plus 5 divided by 0 minus 3. The answer is negative 5 over 3. That's the answer for part D, or the left hand limit of this function as x approaches 0.